Welcome back, and this is why we prototype stuff. We haven't run into a problem, but this is indeed going to be a tight fit over here in this corner with this larger Alps volume pot and this octal tube socket. As you can see, it bumps up against it, but it's also got this lip here where it's going to sit this much deeper into the chassis after the hole's drilled, and I think this little lip might just go under the edge of this volume pot, but I don't think we need it to. And I don't want to have the clearances that close where, you know, replicating this, if the clearance is off just a tad, that the stuff's not going to fit. And so I measured this little file. This is 2 millimeters, and I'd like to have, I think, a 2 millimeter gap right there would give us a little bit of breathing room. Let's see if I can tilt that up a little bit. Give us a little bit of breathing room, just moving it away about like that. And so to figure out how far this needs to be moved in the front, we're going to measure from the front edge to the back of the volume pot. And that comes up to, if you can see, it's 26.5 millimeters. And so then we measure this, and that's right at 25 millimeters. So if we take half of that, which would be the center of that socket, would be 12.5 millimeters, and add it to the 26.5 millimeters here, that gives us 39. And then we add our 2 millimeters, puts us at 41 millimeters from the front edge. So I'm going to flip the chassis over, and we're going to measure back 41 millimeters. Put a very light little mark, because we want to come back this way, and we're going to put it 41 millimeters from that edge too. So we'll mark, that's going to be our center point. And remember, we're punching a pretty big hole out here, so little marks like that aren't going to be seen. So our 41 millimeters here is going to be dead center on this output transformer. So we're going to go ahead and measure off the other center of the output transformer to put our other tubes. And that's 127 millimeters. So we'll make a little mark there. And then we'll come in with our 41 millimeters from the front edge. And we'll mark it right there. And then just to make sure we don't get confused, we'll mark that with a so there's our one tube socket center, there's our other tube socket center. We'll go ahead and take the volume pot out, because we know where it was. And then after removing the volume pot so that we don't damage it, we'll come in and center punch our 2 front tube socket holes. And we got those ready to go. So next we'll drill a couple of pilot holes and then double check our measurements. So this one should be 41 millimeters from both edges, which it is. And then this one should be 41 from the front. And then we will double check that 127 is the center of this one. And it is. And we'll go 127 there. So the next thing we need to figure out is where we're going to put our back row of tubes in relation to the front. And I think they'd look good if they were all in a line here. Even though like these two and this tube are going to be fairly far apart, it'll just help with the symmetry of the amplifier. So we want to pop this output transformer where it's going to be sitting. And then put the choke up here. And if we measure between these two, it's 90 millimeters. So if we center this tube, I'm not even going to make a mark. I'm just going to kind of hold that right there with my fingernail. And I want to try what I used on my other amp, which was 112. And that's exactly dead center between these two transformer, or between the transformer and the choke. So let's go ahead and put the two output tubes 112 millimeters back from the front edge. So we're going to put a little guesstimate mark there, just kind of trying to look at what the center line would be. And then come down here and do the same thing. And now we know we want to be 41 millimeters from the side here, like that. So that hole's going to be right there. And then we'll measure across here. Which is our 127 millimeters. And put a mark right there. Now we would like to keep this rectifier tube as far away from the rest of this as we can. So if we determine that 41 millimeters seems to be a good distance from this edge, and so to try to keep things symmetrical, I'm going to say let's go 41 millimeters in from this edge. And then again, we're going to get our 112, which is that distance there. And mark that. And come in with our 41. And extra mark that. And then here's our marks. We got this one, this one. Let me just double check these. Yep, 41. And then, so it's this one, and then right there. So let's go ahead and punch mark these, and then we can drill all our pilot holes. And then so let's drill these out. And then we're going to go up to, again, we're going to be using this Greenlee punch, and we're going to have to drill a hole that big. But let's go ahead and slowly step up to that size so that we get an accurate center on all these holes. Get a fresh battery in the drill. Move our piece of wood down to these two front holes. Clean up our chips, and then get the right size for the bolt, the draw bolt to go through the chassis for our punch. Again, when you're doing these larger holes, especially when you're stepping up from like this size up to what we're drilling, don't put a lot of downward pressure on the bit. Just let the bit chip through the hole for you. Let's get centered over the wood here to these three holes. Hopefully we got the right size hole. One thing you want to know too on these green leaf punches, you want the hole to be very close to the size of the bolt. You don't want to go like way oversized, because then you lose the centering that the bolt provides. And slightly too small. Let's see if we just waller this out just a little bit, if that gets us where we need to be. Like I said, we want a tight fit. And I think the next size drill I have would probably be too big. So we're going to do that to all these. That. And fits perfect. So now we want to get a sheet of paper to protect the top surface. Get a sheet of paper. Put the bolt through it, put that through, come in from the bottom, start our punch, and as you get close to it's snugging up, just give it a little wiggle. And off camera I did put just a little coating of grease onto the cutting head so it cuts through the metal easily. And then you'll hear one pop, and then you'll hear a second one. There we go. And we got a beautiful round hole. Now we need to do that 4 more times. And then we'll stick the volume pot back in and see how well we measured the gap between the volume pot and the tube socket. I'm going to see real quick. It's perfect. Just making sure I didn't do something real stupid and pick up the wrong die. Move some of this stuff so I can be on camera here. But when I finish this one, if this all comes out like I want to sit down and just kind of go through making one more of these off camera and see how much of a time investment this is. Honestly, this may end up being too big of a time sink for me to want to do these by hand. even on a limited basis? And if so, I mean, if I end up spending 2 or 3 hours in hand fabbing each one of these, I'm not sure that's something that I want to spend hours and hours and hours and hours doing that kind of repetitive work. So what I may end up doing is go ahead and talking to one of our local fab shops and seeing what they would charge to do a batch of these, and then honestly see if there's enough interest to bother even doing this. Because one thing too I was thinking about is this is actually a very common layout for any kind of single-ended amplifier. And it wouldn't have to necessarily be the 6SQ7. I mean, this would work with, you know, using any kind of octal tube for a driver, and then an octal tube for a output tube. You could do this with a KT88 amp or a 6V6. You could have a 6SL7 or 6SN7 driver. You could have a 6SL7. And I know they make little adapter kind of plates that bolt in here to adapt an octal socket to a 9-pin socket. And that opens up a whole bunch of other possibilities for, you know, installing tubes. Or you could have the, you know, the 9-pin tube countersunk down into the chassis a little bit. That's kind of a neat look. And so the fact that this could end up being kind of a generic prefabricated SE tube chassis might really open up the number of people that would be interested in purchasing one of these, and, you know, make it worth seeing if a fab shop would want to, you know, fab up 50 or so of these. So this is our next to the last hole, and I hope in seeing this you really see the value, even if you're only going to be building one of these, of investing in one of these green leaf punches. The other thing that you can do is buy one of these like used on eBay, and then when you're done using it, just turn around and sell it on eBay for the next person. And then it acts kind of like a rental program. You probably won't lose any money. Have a little hassle in having to, you know, order one and then box it up and then have to resell it. But it's a way of doing this without having to spend money on buying a new one of these punches. And this is a pretty common size for this punch. This is the 1 3/16. So let's punch this hole out here for our rectifier tube, and then we'll have all of our tube socket holes punched. And you can see this isn't easy to turn. Even with this little ball bearing thrust washer, they're really bad if you have just the friction washer on there. So make sure you spend the extra money and get one that has this little triple layer ball bearing thrust washer. Without it, it's real easy to like bend up the top of the chassis. Okay, so the next thing we want to do is put our volume pot back in place and see how well we measured this hole that we put in the front. And yes, I have no idea if this is going to fit or not. So you'll get to see live on camera me cussing if this doesn't fit. But I'm pretty sure it's going to just clear. There we go. It's a perfect fit. We got the wires far enough away. So the last thing we want to do is make sure we're orienting the pins and the tube sockets right. And we don't want to get the heaters near this potentiometer. And so on the 6SQ7, with the key going this way, these two pins are the heaters. We can lay these down low and come up and run them up to the output tubes. Do the same thing over on this side. So that'll give us a good path for the heaters away from this potentiometer, and then we can run the signal wires to the RCA jacks up and over in this upper, or would be the lower corner, and then to the RCA jacks. So it should be, keep them shielded and cleared away, even though they're shielded wires, keep them away from any noisy AC. And I do feel it's okay to like chain these together, having the power tube and then the signal tube, but not the other way around. I don't like powering the heaters of the power tubes daisy chained to the signal tubes, because I feel like then you're got extra current and more heater wires running around these sensitive input tubes. So we're going to run the heaters from here to here, and then across over to here, and then here, and then across over to here. There's not a lot going on right here, and what is going on right here, we can run at 90 degrees to the heaters, which is just the wire from the output transformer to the plate. So anyway, I think that orienting them in this direction is going to work well. And it also gives us a place to put a tag strip using the hold down screw for the tube, because I want to try to not have any visible screws on the top of the chassis unless we have to. The only thing left that I'm in a quandary about is how to deal with the cathode bypass resistors. And I think you've seen, or I've talked about on some of my other amps, I like putting them on the top deck of the chassis so that the heat isn't down here trapped underneath the chassis. But I'm also not sure that that's something I would want to do or recommend on a, production, or an amplifier that somebody might have around little kids or pets or something. So we may end up mounting them to the underside of the chassis and drilling a couple little holes on each side of them for heat to rise up past them and come out of the chassis. And that's probably a safer way of doing it. I mean, on my own personal amps, I'm going to mount them on the top. Again, if I'm going to be, having these things made in like mass quantities, I'm not going to be able to be as optional about like what you're able to do. It's like, here's the chassis, kind of take it or leave it thing. And obviously having them, mass produced is going to make them a lot cheaper. So anyway, we may be getting at the end of this video, and it might take a little bit to show you how I measure and drill the holes and stuff for these tube rings that we're going to put on this amp. And if you're not going to use the tube rings, all you really have to do is, find the center of the slot, punch it like that and like that, start the pilot, look at the holes, make sure they look like they're centered in these slots, and then drill through, and you're done. And I don't think that's super complicated. So obviously I'm not going to do that because that's not the route we're going with this amplifier. But I will show you how to measure and use those decorative tube rings if you want to use them on your amplifier. So anyway, hope you're enjoying the series. If you are, please subscribe. Please like the video. And I'll see you soon for more 6SQ7 fun. Have a great day.